All right. People are still checking into on campus. That's fine. If you haven't, please do that. Uh, Today, I want to do a couple of things. I want to go over some of these questions on the homework. I want to review just a little bit about what we've done, and then I want to introduce a different set of trig functions, which work pretty much the same way. They just have different names and different ratios. Okay. After that, then I'll introduce the homework, and then I'll after that I will be in teams to answer any like really specific questions. Okay. So if I don't answer your question on the homework, that's fine. Uh, on teams, I can address that. All right. So questions on homework. So this was what you were supposed to answer in that attendance prompt. Um, 16, 14, 18, and 12. I'm going to do number 18 first because that's actually one of the simpler ones. So number 18 gives you this diagram. And we're asked to find the sine of theta. Okay, and you still do the same thing. We still need to know what sides we have and what sides we don't. All right, so in order to do that, we're dealing with this angle theta. So in order to find the opposite side, draw a line from theta to the other side of the triangle. And the hypotenuse, if we draw a line from our right angle to the other side, that's our hypotenuse. Okay, and from SOHCAHTOA, sine is opposite over hypotenuse. Okay, so we defined our sides, we defined what sides we need, and we don't actually need to find any other side. We already have it. Okay, so our opposite side is 9, and our hypotenuse is 15, which then can simplify into 3/5. And then we're done. So questions on 18. All right. So then we'll do, let's say 16 next. So 16 gives you this diagram. And it asks for tangent of theta. All right, so tangent is always going to be opposite over adjacent. So we need both of those sides. All right, and that angle is this. All right, so again, the first thing we do is we just define what sides we have. All right, so in order to find the opposite side, we start from theta, draw a line to the other side of the triangle, and that's our opposite side. In order to find the hypotenuse, we start at our right angle, draw a line to the other side of the triangle, and that's our hypotenuse. And then the other side left, that's our adjacent. Okay, so we have adjacent and hypotenuse, but we do not have opposite, so we need to find it. In order to do that, we have to plug in to our Pythagorean theorem. Then we substitute in what we know, and we solve for what we don't. So 3 squared is 9. We still don't know the opposite squared. And then 3 rad 5 squared could be rewritten as 3 rad 5 times 3 rad 5, which then we have to multiply these 3's and then these 5's. So square root of 5 times square root of 5, that's just 5. So then we have 45 is equal to 9 plus the opposite squared. Okay, so before I go further on this question, are there any questions about what I have up on the screen? All right, so then we have to solve for the opposite side, because we want just the opposite, not the opposite squared. All right, so in order to do that, we have to subtract 9 from both sides. And we get 36 on the right-hand side. Now, again, we want the opposite, not the opposite squared, so we have to get rid of this square. In order to do that, we take the square root, and because we do it on the left-hand side, we have to do it on the right-hand side as well. And that leaves us with just the opposite. And then the square root of 36, that's just 6. So now we can substitute into our trig function, where the opposite side is 6. The adjacent side is 3. So 6 over 3, which is just equal to 2. Questions about number 16? All right, number 14. 14 gives us this diagram, and we're asked to find the cosine of theta. All right, so again, the first thing we do is we just determine what sides we have. All right, so to find the opposite side, we start from theta, draw a line to the other side of the triangle. That's the opposite side. To find the hypotenuse, we start from the right angle, draw a line to the other side of the triangle. That's our hypotenuse. And then the other side left, that's the adjacent. All right, and cosine is always going to be adjacent over hypotenuse. Okay, so we have the adjacent and the opposite, but not the hypotenuse, so we need to find that. And again, we do that by setting up our Pythagorean theorem. And then we just simplify really. So 14 squared is 196. (196) plus 196 is 392. So before I solve for that, just the hypotenuse, are there questions about what I've done so far? All right, so then we have to take the square root of both sides in order to cancel out this squared. And then we can do some simplifying. All right, so 392, if we make a factor tree, if we take out 2, we get 196. And 196, I guess we can just keep going. That way you can see this a little bit easier. All right, so square root of 392, we can rewrite as the square root of 2 times the square root of 2 times the square root of 2 times the square root of 49. All right, and you can keep going with 49, but I know that 49 is a perfect square. All right, so we can rewrite the square root of 392 as this. And then we can simplify a little bit. All right, so every time something repeats itself, that just turns into what's inside. All right, so square root of 2 times square root of 2 is just 2. Square root of 49, that's 7. And then the square root of 2 just comes down. And we have to multiply all those together. So then we multiply common terms, which is 2 times 7. So that's 14, and then rad 2. So our hypotenuse is 14 rad 2. And then we can plug it into our cosine. All right, so if we do that, our adjacent side, that's 14. Our hypotenuse is 14 rad 2. And then we get to simplify a little bit, or rationalize, right? So that looks like a good answer, but it has a square root in the denominator, which we cannot have. Okay, so in order to rationalize that, we multiply by rad 2 over rad 2, which in the numerator, that's just now 14 rad 2. In the denominator, that becomes 14 times 2, which is 28. And then we can simplify these whole numbers. So we get 7 rad 2 Actually, I can simplify further than that. 14 divided by 28, that's just 1/2. So then this becomes rad 2 over 2. All right, I guess you could put a 1 here, but because it's just 1 times rad 2, you can just rewrite that as just rad 2. Okay, so that one I think is actually one of the harder ones on there. So I'm just going to pause for a second and let you guys kind of just look at it. Are there any questions over any of that? Okay, since there are no questions on this, I think the last one we need to do is number 12. Which gives us this diagram and asks for the cosine of theta. Okay, so first thing, again, we just determine what sides we have. So we find the opposite side. We find the hypotenuse. And then the other side is the adjacent. Now from SOHCAHTOA, cosine is always going to be adjacent over hypotenuse, which then is equal to 24 over 12 rad 5. Okay, again, that looks like a good answer. We need to simplify and rationalize. And I'm going to simplify just a little bit first, because we can simplify 24 over 12. So that just then becomes 2 over rad 5. And then if we rationalize that, we have to multiply by rad 5 over rad 5, which in the numerator just becomes 2 rad 5, and in the denominator just becomes 5. And then that's our answer. Okay, so this is one where we actually don't need to find any other side. We're given what we need. Okay, so again, I'm going to pause for a second. Are there any questions over this problem? All right, so the next thing I want to do is to introduce the new functions that we need to know, all right? So then these are new notes. So you should have a notebook out and then taking notes. And I'm going to want to review just a little bit what we've done so far. So given a right triangle, we can determine sides. So again, that's finding the opposite, adjacent, and hypotenuse. And we have trig functions that tell us the relationships between the angle theta and the ratios of sides. So the sine relationship of theta will always be opposite over hypotenuse. The cosine relationship of theta, that'll be adjacent over hypotenuse. And the tangent relationship with theta will always be the opposite over the adjacent. And we can solve for any one of these sides by plugging in to the Pythagorean theorem. Okay, so this is all the stuff we've done, and we should be at least decently comfortable with it. I feel like we've had a bit of practice. We've gone over a bunch of examples together. This is all we've done so far. All right. What we're going to do now is we're going to add a different set. So this is kind of like our regular set of trig functions. And now I want to introduce the reciprocal. Okay, and reciprocal, we've talked about that a bit, especially when adding fractions. The reciprocal of something is just when you flip the fraction. So the denominator becomes the numerator, and the numerator becomes the denominator. Okay, so the reciprocal of sine is called cosecant, and that will always be hypotenuse over the opposite. Okay, so it's just another relationship with the angle theta, but it is a different ratio between sides, and that ratio is just the reciprocal of the sine ratio. Okay, the reciprocal of cosine is secant, and secant of theta is the reciprocal of cosine, so it will always be the hypotenuse over the adjacent. And then the same thing with tangent. So the reciprocal of tangent is called cotangent, and that relationship will always be adjacent over the opposite. Okay, and all the same stuff still applies, right? So we're still finding sides, we're still rationalizing, we're still dealing with radicals, except now we have these reciprocal functions to worry about. Okay, so I'm gonna give you a second to kind of catch up on writing if you haven't, and then I'll go over an example or two. I'll introduce the homework, and then we can start that. Are the problems going to be the exact same? Otherwise, yeah, everything that you do is going to be the exact same, except your ratio is going to be flipped. Okay, so let's do an example or two. So before I guess I do an example, um, if you go to on campus, go to topics, go to right triangle trig, we're going to be working on this worksheet right now. And that's got a lot of examples. This is not your homework, but it does have a bunch of examples with reciprocal functions. Same with the two above it. So if you need just a little bit of extra practice with the right triangle trig functions, these two are here for you. But right now we're working on this reciprocal functions of trig ratios. Okay, we'll get to the inverse stuff a little bit later, but right now we're working on this middle one. Okay, so if you open that up, you will get this worksheet. Okay, and again, this isn't for homework. I might give you homework out of this, but not as of yet. But I will be working from this for a couple of examples. Okay, and the example I want to work on is just number 1. And number 1 gives you a diagram with 2 side lengths and an angle theta. Okay, but it's asking you for the cosecant of theta instead of the sine, cosine, or tangent. So again, same process. The first thing we do is just define what terms we have. All right. So if we draw a line from theta to the other side of the triangle, we get our opposite. Draw a line from our right angle to the other side of the triangle. That's our hypotenuse. And then the other side is our adjacent. All right, and cosecant from our new trig functions is always going to be the hypotenuse over the opposite side. And again, just like the last trig functions, we have the hypotenuse and the adjacent, but we need to find the opposite. So we plug it in to our Pythagorean theorem. And we solve. Again, so everything we've done up until this point is pretty much the exact same. Okay, and then we need to solve for the opposite. So we subtract 36 from both sides. When we do that, we get that the opposite squared is equal to 28. And then we need to just solve for the opposite, so we need to get rid of this squared. And in order to do that, in order to undo that square, we have to take the square root of both sides. That leaves us with just the opposite is equal to the square root of 28, which we can simplify. So I can rewrite the square root of 28 as the square root of 4 times the square root of 7, which is equal to 2 rad 7. Okay, so I'm going to pause there just for a second. Are there any questions? What do I have so far? All right, and then again, like normal, we plug that back into our coefficient, our trig function. Why did you rewrite 4 as 2? The square root of 4 is 2. All right, so there's a difference between just 4 and the square root of 4. Those are two different numbers. The square root of 4 is equal to 2, right? Because 2 times 2 is 4. That's what that square root is asking. Okay, so then we can plug this into our equation. So our hypotenuse is 8. Our opposite is 2 rad 7. And then we can rationalize. So we need to multiply by rad 7 over rad 7, which gives us 8 rad 7 over 14, which we can then simplify as to 4 rad 7 over 7. And that is our cosecant of theta. Okay, so again, I'm going to pause for a second. If there are any questions at all, please ask. I know that this is pretty similar to what we've been doing the last 2 days. That's okay. I want to make sure we really, really know this because this shows up a whole lot, both on the ACT next year and even a little bit in calculus. All right, so if you have questions, please ask. Okay, all right. So this is exactly what we've been doing, just with a couple of different ratios. Okay, um, It seems like people are more and more familiar with this, so I'm gonna close this here in the next like minute or two. Your homework is R2, which is very similar to R1, except we're dealing with these reciprocal functions. All right. Um, while you are doing that for the next like 20 to 30 minutes, I'll be on Teams to take like individual questions. So if you need help, go there. Okay. I'll leave this open for the next like minute or so. If I need to answer any broader questions, I will. But after that, if there are no questions, I'll go to Teams. All right. So I'll close this. I'll hop on Teams in the next 2 minutes, and I will help out. I will gladly help out people there. All right. So closing this, and I'll see you in a couple of minutes.